So today's webinar is about Ansys Discovery, and we are particularly focusing on the structural part of it. So let's go and see what the goodies we have. Hopefully my voice is reaching you nice and well.
It sounds good, Mikko.
Thank you. So welcome everyone. So before we actually start to show you some live presentation, the actual software, we will show you a few slides. And at the beginning of the slide deck, I have a 1-2-minute video that kind of gathers together all the kind of fun technological highlights what Discovery has to offer. So let's go with that first slide now.
Whether you're an engineer or analyst, your simulation journey now starts with Discovery. Powerful geometry modeling and simulation pre-processing, groundbreaking ease of use, and expanded simulation capabilities makes Ansys Discovery the best tool to accelerate innovation and increase productivity throughout the product development process. The addition of Ansys associated CAD interfaces, history tracking, and a connection to Ansys Workbench makes Discovery part of an automated and connected workflow that seamlessly integrates third-party CAD tools to the rest of the Ansys portfolio. Discovery includes porous media modeling to represent flow-resistant regions such as filters, screens, or perforated plates. Combine this with improved conjugate heat transfer, modeling for fast, accurate simulation of electronics cooling, heat exchangers, and engine cooling. If at any point you need additional guidance, turn on the overlay help that helps provide interactive, in-context information about everything Discovery has to offer. Working with bolts, Discovery's expanded physics conditions, such as torque load input for pre-tension bolts, puts the setup experience in terms that every engineer will understand. Ansys Workbench connectivity now allows analysts to do the geometry preparation for simulation and Discovery, and then associatively transfer the model as part of a connected simulation workflow. If you're working with another CAD package, easily update your simulation with the new design and pick up right where you left off in Discovery, or simulate more complex physical behaviors with direct transfer to Ansys mechanical and fluent applications, as well as access Discovery on the Ansys cloud through your browser if you don't have access to high-performance hardware. Workflow enhancements such as save scenes, physics condition suppression, and connections to Grantis Selector and MI accelerate and automate this simulation workflow from setup through to report generation. Take advantage of the first ever interactive topology optimization and leverage simulation to inspire and uncover optimal and innovative design solutions driven by loads, materials, and constraints. Topology optimization capabilities can account for manufacturing constraints such as 3-axis milling and overhang prevention, making it easy to get a usable result the first time with Discovery. There's much more to Ansys Discovery than just what you saw. Integrated geometry modeling, rapid multi-physics simulation, industry-leading accuracy, and a radically easy-to-use user experience sets Discovery apart from other design tools. This is the promise of design exploration made simple, because every engineer deserves the power of Discovery.
So that was kind of an introduction video to Ansys Discovery, and as you might already seen, there's a lot of kind of fun, good things in that one, starting from the user interface and ease of modeling. So how does this Ansys Discovery actually works is that you have 3 different modes in it. You have so-called model mode, where you prepare your geometry, fix possible gaps, alter it a bit so that you can check that what would be the effect of some geometrical changes be. Then on the other hand, we have explore mode, where you are running the actual physical simulations of the fluid flow or structural it might be. And the thing with this one is that they are actually run in your graphics display card as a GPU. So they are fast and they are live. And then on the other hand, should you want to go even further away or further or deeper in the solutions, you can go for refine mode, which then enables you to go deep down with the Ansys flagship solvers like Ansys Fluent or Ansys Mechanical. And it really gives you a greater kind of fun accuracy and much more kind of available physical options for you. So that is, I would say, the kind of a basic building blocks of the Ansys Discovery. So when you start Ansys Discovery, it starts with the explore mode, and most likely you will just import some geometry to in. And should you want to fix it, then you go for model mode, where you can fix and alter your geometry, and then back for your simulation environment. And then you can, at the end of the day, verify the results with the refine mode. That's kind of for the use case in there. So question is like, who is this kind of fun application then intended for? Is, I would say that basically there's a twofold thing in here. On the other hand, this will enable kind of more and more engineers to use simulation, so that you will get your kind of an overall design time down, just because you can incorporate more and more simulation to your design work, and that's kind of enables you to find the solutions faster and faster. On the other hand, the kind of expert users can also benefit this, so they can have kind of a easy to use tool that they can fix and test some ideas, make some concepts, and still they can upload their models to the flagship solutions and really go deep down in there to find out that what are the actual or precise kind of solutions for some of the physical problems you might have. So if I just have to somehow highlight the key kind of capabilities of the Ansys Discovery, I would say that you have this embedded geometry preparation in there, should you want to change something. Then you have this live physics, which is instant one. Then you have a high fidelity simulation in the refine mode. And then the ability to really to transfer all the simulations results that you do in Ansys Discovery to Ansys Fluent or Ansys Mechanical environment. And on top of the cake, as a cherry, you have a seamless CAD connection, which enables you to transfer the 3D CAD like parametric designs directly to Ansys Discovery and even make them update. So let's see a bit more about these capabilities on the following slide. So when it comes to geometry preparation, since there is a kind of a CAD in the model mode, which is called space claim, and we can do this direct modeling kind of a tricks in there, just track the phases and to make sure that the geometry is perfect for our simulation use. It's very kind of effortless, and on the other hand, kind of what's good in there nowadays is that you have this history tracking feature in there, so any alteration you do with the actual CAD geometry is restored even after CAD geometry update from the CAD. So it really makes sense to sometimes have it kind of two layers of the changes in there on the CAD geometry and on the other hand on the simulation geometry. Then the actual simulation part of it, the Ansys Explore mode. If you do some changes in there, let's say the input parameters like a velocity or the change of geometry, the results will update instantly. And that's very nice to try to find out that, okay, what are the effects if I just tweak this a bit? What will happen if I just do something small in here? So in order to concept out that what do we get if we change something? Would this go bad or better or worse than on the original design? So it's giving you quite a lot of time saving rather than going the full-blown simulation tools with the flagship solvers. But then on the other hand, when you are going to deep enough with your live physics, you can go and drill down even further with the refine mode for the high fidelity simulation, where we start to use the Ansys Fluent and Ansys Mechanical solver, do the meshing kind of things in there, and then get, for example, conjugated heat transfer calculations done in a precise matter all the way. So then if we still keep highlighting these things, when you are doing something in the Ansys Discovery, you do have the buttons to push the geometry or the predefined simulations to either to Ansys Workbench, Ansys Mechanical or Fluent. And in the background here, we can see the Workbench user interface where we have pushed Ansys Discovery geometry, connected that to Fluid Flow system, and there we can go for setup and go instantly to Fluent, should we have the license for that one. So whatever you do at the Ansys Discovery is reusable all the way to the flagship solutions. And on the other hand, if we're combining here any kind of a CAD model, we can also have the CAD geometry here, and we can basically make parametrical change loops here in order to vary things. And that is also the great power of this one. What CAD systems do we support? Basically, cryoparametric and all the rest of the 3D CADs out there, and then of course the neutral formats, and also the updating them via the kind of software links. If we're still keeping up talking about this CAD connectivities, is we are basically the reseller of Creo parametrics. So how does it actually work? Let's say that we have some geometry on the lower left corner here. Let's say we have wall thickness as a parameterizable dimension. And if we publish that thing to Discovery by using this kind of a Creo parametric kind of a button, what you got in toolbar, then you'll have the thing in here, and it will be as a parameter on the Discovery as well. If you even further push down to that Workbench, you have the Discovery object in here, and then you go for static structural, and surprisingly, you also have the same dimension in here, which enables you to run this thing on the Ansys Mechanical. And if you have some results like maximum volume stress or displacement, then you can add that as a second parameter. And now you can basically launch a parameter study which varies the 3D CAD geometry, push that all the way through this kind of an Ansys Mechanical, and you get the full-blown results in here. So you are able to drive your judge geometry from the Ansys Mechanical via Discovery. And that's very nice option as well. So basically this enables you the scalability of the simulation. Whatever you do at Discovery is restored, and you can reuse that as an expert level here as well. So question, what can you simulate in Ansys Discovery? You can do structural things, fluid flow, thermal analysis, and topology optimization. Today, we will just concentrate on the structural simulation part of the design. And we will have later on the fluid flow simulation webinar so that we can drill down what goodies are embedded in here. So, without giving you any more headache on the PowerPoints, let's go for the live demo and see how the application actually looks like. And when you open up the Ansys Discovery, it opens up like this. And kind of a thing that I want to highlight here is that you have this kind of a splash screen, which typically people are clicking always this class close. But in this case, I'm not going to do that. I will just go forward in here. And as you can see, these are actually embedded videos where you can actually go forward and see that, okay, this is a bit of like a help. Then there's a more videos like that will show you different things on here. So basically getting started with this one is quite fast and quite easy. There's a good load of useful information embedded right in your front of you at the startup of the system. So I will just close it and open up my geometry, which is a kind of a suspension system, and we try to do some kind of a structural simulation in there, just to show you what is the general workflow and how things work in here. So as you can see, we have the CAD geometry here, and if we are taking for the user interface components one by one, on the lower right corner is the stuff that we are used for controlling simulation activities, visibilities, and actually solving things. In here, as you can see, we open it up in the Explore mode, but if you want to go for the modeling mode, you just click in there and then you are in here. There's a 3D modeling related tools in here. Export mode, you have more like calculation things, and then we have the refine mode here at the right side of it. Should you want to go for more like a more advanced things. Then what shall we do in here is that on the lower left corner, we have this kind of fun. Of course, we have ability to rotate this thing, but sometimes you just want to rotate it for particular direction. So this is quite handy for that one, for viewing things about certain direction. Should you want to go for a home view as a default view for something, and so you can basically control the views and the visibilities from here. Is it colorable material or make it things transparent? Everything is available from the lower left corner. Then if we take a look at our model tree on the upper left corner, there's this kind of hide and show things. These are just, visibility things. But on the other hand, we have an exclude from simulation button here as well. So we can exclude some of the components away so that you are not using them in the simulation, and also hiding them from the display, which basically leaves us with just a geometry that you want to use for the simulation. We do still have some remaining fasteners and stuff that we really don't need, but they are still floating around here. So question is, how do I remove them? Well, let's just start working with this one. I just paint basically, or select with it as a window box selection in here, hit the right mouse button and hit the exclude from simulation. Now they're excluded, but on the other hand, still visible. If I say hide also suppressed, then they will be gone as well from the display. Then if it is enough for me that I would just click for one surface of these individual nuts and bolts, just to make sure that, you know, all of these bolts and nuts are not really required in this simulation, I will basically remove all of them away. Of course, I can do this from the model tree, but it might be a bit more visual for me to explicitly exclude that one from the simulation, and then on the other hand to keep track on what I have been doing, hide or suppress, and now my simulation geometry starts to take a form of what I want. So we have an early suspension system in here. Well, next thing, what I usually like to do is to add a boundary condition or constraints in here. So basically make sure that somebody is holding this from these holes. On the other hand, these are the holes. And in here, as you could see, that we have these shock absorbers and dampers in here and springs. So the case that I want to simulate is that when this thing will bottom down, so somebody is driving this thing and it hits pothole, and this will just, you know, push as high as it can. So basically what I do is fix these, you know, pivot points in here, but also I will fix these kind of brackets as well. So let's go and do it. Well, the user interface components, I have one more in here in the middle of the screen, this kind of a hexagonal. That if you click that, you can decide that what do you want to do. I want to go for structural simulation. I want to go for supports. Let's click that one. Then this kind of a heads-up display is now giving me a possibility of just starting making a constraints. I'm holding my control key to have a multi-select. And instead of making it fixed constraint, I'm willing to make it hinge. So basically this is now able to rotate around. I will accept or hit the enter. And then my physics tree in here is getting populated. So should I want to go more, I still have this hinge kind of a pre-selected. If I go in here and click once, click second time, and accept, I get the second hinge support in here. So I don't anymore have to select the type. Second nice thing in here is that if I want to select this hinge one, I cannot even select the planar faces. I have to have a cylindrical face, which are coaxial, in order to them to be able to get here or to be selected. So now we have a tree of them in one row. If you want to get rid of this heads-up display, just hit the S button once and it's gone. So that's pretty much how you put the boundary conditions. Then, of course, the next thing I want to do is put some forces in here. Maybe select my geometry first, then click my button in here in the middle of it, and then put the force in here. Not the displacement. Where's my force? There's the one. And click the force in here. And the force direction is initially picked by surface normal directions and stuff like that, but you really don't have to care about that. So question is, how about the force value? If we are putting here, let's say 1000, let's not put a Newton, let's put Lips instead. So you'll get your force in here. So we don't really care about the units. You can put in whatever units you want. Then this properties dialog here is something to look for. You at the moment have a direction of negative y. If you want to make this upwards, just put a positive in there. But sometimes you want to put it so that the direction is not really, you know, parallel to y, parallel to x. It's something multiple. You want to just have a resultant. So then you can set the direction in here and just pick the edge, for example. And now, as you can see, it's a y and z in here, but the sum of the force is still the 1000. So it's quite easy to kind of put the forces in the system. And then I hit a few times the escape just to get rid of there. Anything else? Well, at the very moment, what do we have in here is the constraints done, forces done. We do have a material which by default is structural steel, and we do also have a gravity in here, which by the way is totally wrong direction. Let's go for negative y, and now it seems to be a bit more in place as well. So should I want to do a simulation now? It's possible, but before that I want to introduce a new kind of a set of nice features what the Ansys Discovery has to offer is, and these are the kind of fun monitor graphs. And these are handy to understand what is happening in my simulation. I want to know the maximum displays and maximum volumetric stresses in my model while I'm doing changes. Of course, I have something else as well. So if you go for monitors and you go for custom, you also have something else available, and let's go for mass. Since this is part of a vehicle, and most likely I want to minimize my mass as well. So having that mass kind of indicator there somehow makes sense as well. So should I now want to run it, I just click lower right corner and say solve, and this system should be solved instantly within a few seconds. And now we do have results in here. If you want to change your units, you just go and change them. And as you can see, we do have first kind of a result point here, which says, okay, we have something displacement level, stress level, and the mass is around 18 kilos. And this kind of reminds me that, oh, it's a vehicle. Maybe I want to change this to aluminum instead. So let's do that. So if you just go here and triple click, you get the kind of bodies in here. And then you can go in here and say aluminum. Just start writing, and you do have the full list of available materials around here. So for some reason, it's 1661, T1 to T6, what I want to use. And let's go with that one. Should you want to see some physical difference in the, like, for example, color in here, you can always go and say edit. And I would like to have a bit more information. Appearance, color for aluminum should be maybe light green, so that you can really see that, okay, what's going on in here. So all my aluminum components are now light green and steel are basically white. As you can already see, instantly I changed this one. My calculation also updated, so my mass went down because of aluminum components, but on the other hand, stresses went up, displacements went up. Okay. Then let's take a look at the results a bit more detail or carefully. What do we have at our hands? So in here, if you look at this lower joint, and if we want to make it animate, you will see that this is pretty much fixed. It's like a welded on, and there's no slippage between the bolt joint in here. So should you want to play around with the joints, that's also possible. And let's do that because it's possible. So at the end of the monitor, you do have this kind of connections folder or group, and it will show you the connection. You hover your mouse over it as a kind of PDS Vision Rosa Coral perhaps. And if you double click that one, you get this pink and blue kind of display that shows you that, okay, here are my contact pairs. And we have some contact options here. We have, first of all, exclude from contact detection, so they don't really care the parts about each other. Then you have a permanent bonded, which is kind of a welded or glued together. Then we have ability to convert it to joints, so they are able to rotate around each other. But then on the other hand, we have a sliding contact in there as a possibility. How does this system kind of works here? You can select either bodies or surfaces. So let's select the bodies. If I click this one, I get all the 4 contacts which are associated with this particular shaft. And I want all of them to be basically permanently bonded connections. Now, as you can see, there's 13 contact pairs left from the initial 17. Then on the other hand, even though we have these pink and blue colors, we have these small kind of markers, spherical ones. If I click that with the control key that, and with the control key that, we do have 3 contact pairs here and more, which are related to screws. So again, in here, I will say, let's convert these to permanently bonded. So now we have a second set of things. And we are left with 10 contact pairs. Of course, what we could do now is to convert them to sliding. But on the other hand, we can have a bit more kind of a user interface in here. You can say that default connection behavior is not bonded. It is, by the way, sliding. So all the first 10 of them are now slided contacts by default. So now they're able to glide on top of each other so that they don't penetrate, but they can separate basically. And if we now say that, okay, the computation would be nice, just click this one, show me some results, and what do we have? Let's go in here and see that, okay, let's animate this a bit. Now, you should be able to see that this is actually now starting to glide. What will happen in consequence of that? Of course, the displacement will increase, but on the other hand, all my stresses are also increasing. Mass, obviously, is still the same. Mass doesn't really change because of the change of the contact behavior, which is a right thing to happen. And always you have this kind of a user interface piece in here, which states that what will happen to your factor of safety. It will go down, maximum displacement will go higher, and so forth. So this is kind of an indication of what is happening in your model while you're computing it. Then if you want to still kind of understand a bit more about the behavior of this model, of this geometry, there's a possibilities to further enhance this. So let's go and say distributed force, which we have 4,400 newtons or 1,000 psi force. If I click this as add a parameter, now that's a parameter thing. And what that enables us is that you can have variations in your models. So I click that and just add one more in there, maybe two of them. So I have totally 3 different ones. So let's go that I want to have a kilonewtons because that's a handy thing to have. And let's have 1 kilonewton at the beginning. And I have, let's say, 2.5 kilonewtons. And at the end of the day, 5 kilonewtons. Not newtons, kilonewtons, come on. Now it's about right. And then what I can say is, okay, solve all of them. And what I want to see is a graphics in here. So this is kind of a great thing to have if you want to probe or study your model parametrically that, okay, what will happen if I increase the force? What will happen if I increase the wall thickness? What will happen if I increase the, let's say, the flow rate? Or make it more like kind of a diameters to somewhere, some more phases that we are limiting the fluid flow, for example. What will happen? And in here we are having this force on the horizontal axis. On the vertical we have factor of safety, so we have this kind of parabolic relationship. But on the other hand, if we are changing this to, let's say, force versus maximum displacement, we have pretty much linear relationship in this system. On the other hand, maximum stress 1 meters on the right left vertical axis is also a kind of a linear relationships, which we kind of anticipate to the fact that this is a linear mechanical analysis. But nevertheless, it gives you a nice set of tools to probe that what's going on with this model and what are the kind of pain points of it and how it will behave on the different kind of scenarios. So then something more, if you wanna, since this is now, how would I put it? Simulation run in the GPO mode, which is a fast one. First of all, we have this size per view, which is kind of giving you idea about the size of the 3D element we are playing, calculating the system. It's around 2.45 millimeters. So if I wanna somehow change this one, then you have this kind of a fidelity graph at the lower end of the screen. You can go in here and say, let's go for the maximum. And then you have a bit more intense kind of final mesh in there. Computation takes a bit more time, and then you get the results, and my graphs are also populating up. So if I want to go for 1 meter stresses for some reason, let's go for megapascals. And let's limit ourselves to, let's say, 50, just to get some kind of a result from the stress pattern. You will see that we have something in here. Then, for example, joints, we have this kind of a sliding contact in here. If you want to go, let's stop the computation at this point. If you want to go to refine mode and go again in here to sliding contacts, edit, and then go deeper in here, you have a possibility of going, for example, frictional contacts and with the friction coefficients. But for that, you have to basically run it with the refine mode, which will take some time. And in here as well, what you have is the global and local mesh controls, which enables you to do the mesh that is really required by Ansys Mechanical. A bit more detailed control over everything. On the export mode, however, if we are taking a look at the results, by the way, how you can see that computation is progressing, you can see the small kind of a caterpillar that is running around here. You will see that, okay, some solutions are coming up. One of the ways that you actually kind of look at the results is that now we are looking at the top surface of everything. But if you go in here and say, okay, let's go for highest value, and then the system will change this one so that it will actually show the now the highest value of the simulation. I have to now make some other number in here, otherwise this is not really readable. Now you will actually see this bolt in here, which is covered by other geometry, just because I have this show highest value kind of a filter on, so I can actually see inside of the model in here that where are my highest stress values. So in these joint bolts, stress levels are quite high. At the very moment, I would say that this is pretty much the introduction to Ansys Discovery Structural. So we have a lot of things in here that we can do. The solution kind of solution toolkit is rich, and it has all the features basic normal mechanical engineer would require for initial analysis and some concepting. Same thing goes as well for the fluid flow. But maybe it would be best now to go and talk a bit about licensing and how you can obtain the solution. So Ansys Discovery simulation is basically giving you the geometry modification capabilities and also the GPU-based computation. And should you want to go to have this Ansys kind of a more refined mode things, then you need either Ansys Mechanical Pro license or Ansys Discovery Structural Physics add-on or Ansys Fluid Physics add-on. You basically can have them separately. There is also a HPC add-on, which basically means that you can use more CPU power on the mechanical or Ansys Fluent solutions, so making your solutions faster. Then if you don't have this named user kind of a strategy at your hand, basically you have a floating license, then we have a bit different thing. We do go for Ansys Mechanical Pro and Ansys CFD Pro. So these are full-blown Ansys kind of solutions, and which we can then complement with Ansys Discovery. On the other hand, the geometry interface side, we do have various geometry interfaces, and current parametric being one of them. And should you want to have a richer kind of a materials library, then the Ansys grant the materials data for simulation package is also kind of compatible with the Ansys Discovery solution. Then another option how to get here is to use Ansys Cloud, and basically we do have two different options in here. Either you go for kind of one subscription license where the whole application is in cloud, and basically what you do is use that with web browser, and you have a scalability in there. On the second option is that you're using your own licenses, but you just have hardware in the cloud. So there's various options how this thing can work, and maybe it's best to go there and see case by case what makes sense for just you. And when it comes to this Explore mode and GPU, well, I'm running this on my laptop, so it's not terrible, really kind of advanced thing. So suggestion is to have 64-bit Windows 10. Basically, everybody's having that. You have some decent workstation which has at least 8 gigabytes of RAM, and then you have some video card that is supporting, OpenGL and that. And what you have to have is this Quadro basically chipset, and then some GeForce chipsets also supported just to run the things on the refined mode. Roger, do we have any questions?
Yes, Mikko, we actually have a couple of questions. So a question was around licensing here. What licenses did you need for refine mode?
Well, let's see if I can make this thing happening here. We have two options. Either you go for this named user thing, which is basically a dedicated user, and pricing is a bit different than in floating. So if you want to go on the refine mode, what you need is this basic Ansys Discovery. And on the other hand, you can pick either structural or fluids or both in order to get there to refine mode. That is what you need. Should you go to the floating option? Where's my pen again? come on, in color. Let's change that one because we can. Of course, we need Ansys kind of discovery simulation. Sorry, now I'm drawing whatever I can. How do I undo the last one? Control Z. No, I can't. So what you actually need is the same Ansys Discovery base package, but then on the other hand, floating modules. If you want to have those, you either have to have Ansys Mechanical Pro or Ansys CFD Pro in order to get here.
Okay.
So basically, on the other hand, you can have just the building blocks you need. If the mechanical things are the ones that make kind of important for you, then you go for Ansys Mechanical Pro or the structural add-on. On the other hand, if the fluid flow is, then you go for fluids or the Ansys CFD Pro. But of course, you can always start with the Expo. You're welcome.
Yeah, right. And we got a follow-up question on that actually. So do you have any indication on pricing?
We do. If you're talking about the PTCs, Creo Simulate and the Creo Simulation Live, Creo Ansys Simulation, this has the price level of exactly the same. So that's kind of surprising for me, at least, that the pricing level is pretty much the same. Not to go into specific details, I would say contact your local sales guy and he will tell you the specific details.
Perfect. And that was actually the last question. So what I would like to do before we end the webinar is to point out that on the PDS Vision website, pdsvision.com, you can actually go to ongoing, on-demand webinars and look at the webinars that we have performed before. And we might give a little insight on the new features of Creo 8, for example, which is given by Mikko as well. If you're interested in augmented reality, AR, after services, I think there's something for everyone in here. So pdsvision.com, ongoing, on-demand webinars. And by that, I would like to thank you all for attending. I would like to thank Mikko for giving the presentation. And we'll see you all soon in a webinar close to you. Thank you very much.
Thank you, everyone.